So now in order to extend the series of calculation of pH, we have seen the pH of acids, base and equally mixture of acids. So we're gonna look about the next case. When amount means equivalence of acids and bases are unequal. When amount of acids and bases are unequal. So now when they are unequal and when then any one of the component will be fixed and another will be remain in the solution. So when weak acid and weak base remain in the solution after the reaction with their stronger counterpart, then the type of solution is known as buffer solution. Just understand this line with the some basic example. Like we have a weak acid plus a strong base and they're gonna form a salt plus water. So a strong base here is limiting reagent. So whenever we have remain a weak part and it's salt, okay, it is limiting reagent, it has and weak part and salt, then it is called the acidic buffer. When we have weak base plus strong acid, whenever strong acid is limiting reagent and we have weak base and salt plus water. So since weak base is remaining and salt is, then it is called the basic buffer. So first of all, what is called the acidic buffer and what is called the basic buffer. Now what is buffer, how does it work and what does it mean? What do you mean by buffer solution? We're gonna look further, but first of all understand what is a buffer solution. Whenever a weak part, weak acid or base react with a strong base or acid, like weak acid react with strong base, weak base react with strong acid, and a strong part is in limiting, it is limited, it is a limiting reagent, then it will form salt plus water. Now let's say we have a solution. I'll just simply give you some problems. What is pH of pure water? We say temperature again 25 degrees centigrade. You will answer it as a 7, right? Now you have added pH equals to 7. You have added 3.65 gram of HCl. You have to calculate delta pH. So in order to calculate delta pH, first of all, you will be calculating the concentration of HCl. That is 0.365 upon 36.5 divided by 1. So it will be 10 raised to power minus 2. So concentration of H plus comes out to be 10 raised to power minus 2. So pH will be equals to 2. So change in pH will be 5. And let's again do a problem. In the pH 7, a pure water, you have added 0.4 gram of NaOH. So concentration of NaOH is 0.4 upon 40 by 1 liter we have. And it is 10 raised to power negative 2. So here POH minus it comes out to be 10 raised to power minus 2. And POH is 2 and pH is 12. So here delta pH comes out to be again 5. Now why I am talking about this problem when we are adding acid and adding base, the pH change is very high of 5. In that we have mentioned the amount of acid and base, but still pH changes a lot. So if we have a solution whose pH doesn't change by adding this. So a solution whose pH does not change on addition of small amount of a small amount of acid or base, or by dilution, is known as buffer solution. A solution whose pH doesn't change by adding a small amount of acid or base. On adding a small amount of acid or base by dilution is known as buffer solution. Means pH is not changing at all. So buffer solution contains both acidic and basic part. A solution contains both acidic part and basic part as well. So now what are the properties of buffer solution? What are the properties of buffer solution? First of all, it has a constant pH. Second, pH does not change by dilution. Whenever we it has a constant pH and it doesn't change by dilution. pH does not change on standing it along. Means if we keep a solution for long, steady, or then pH will not change. pH does not change by addition of small amount of acid or base. Means on adding a small amount of acid or base, like you can't add a lot of acid and base powder or whatever, the pH, it will resist the change of pH up to an extent. Okay, then we will be looking at up to what extent the pH does change. But it is not like you have a little bit of buffer solution and you have added a lot of acid. So that is not the act of a buffer solution. So in order to let you imagine that we have a human body, right? We have a human body. So whenever we intake, our blood has a constant pH. Our blood has a constant pH. So whenever we intake like 2 and 3 glasses of lemon water, the most common example I am talking to you, lemon water, and so does the pH of our body changes and it becomes acidic? No. Have you seen someone recommended you not to drink the lemon water because it is acidic and it will change the pH? I'm not talking about drinking the 1 molar HCl concentration HCl. That is not. I'm talking about the lemon water only, which is in daily use. So it doesn't change. So why it doesn't change? Because our blood is a buffer solution. Whenever it has a little bit change in pH, it will resist it, and its pH will remain the constant. Here you can relate what is a buffer solution. Right now, there is a term buffer range. What is a buffer range? So range of a buffer solution range of a buffer solution over which it is effective. Over which it is effective. The buffer solution is not effective on the over range. We will calculate the buffer range for each and every type of buffer solution. So for now, let's only understand what is the buffer range. The range of a buffer solution. Up to a particular range, buffer solution is effective. Like our blood have some buffer range. If you put the acidic or basic part above the buffer range, then it will not be effective over there. Like we cannot add a lot of high concentrated acidic HCl, but then the pH will obviously change. But if I try to limit the range of pH near to our buffer range, then the pH of the solution, pH of the blood will not change. Now next is buffer action. Now what is the buffer action? So action of buffer solution, action of buffer solution on the addition of small amount of acid or base by which it resistant the change in pH. So why is it a magical thing that it doesn't change the pH? No, means not. It is obviously not. So how does buffer works? What the reaction goes on in the mixture of weak acid and its salt, weak base and its salt. So that the action by which the pH doesn't change. So that is called the buffer action. Now let's talk about the types of buffer. Types of buffer solution. A here is simple buffer. So what is a simple buffer? Simple buffer, it has only one component. Like we have weak acid and its salt. Here there we have two components. Here it is only one component. Like salt of weak acid and weak base is a simple buffer. Example CH3COO NH4. It is a salt hydrolysis case. So it is a simple buffer. Salt of weak acid and weak base. Example this ammonium acetate. That is known as simple buffer. Now next part is mixed buffer. It has two component, right? So first is acidic buffer. So what is acidic buffer? It is a solution containing weak acid. If we have weak portion, weak acid and its salt with a strong base. Weak acid and salt with a strong base. Example, we have acetic acid and we have CH3COONA or CH3COOK, the potassium acetate, or we have calcium acetate, or let's say we have formic acid and its base HCO negative with HCOONA, HCOO. Like we have K of potassium formate, sodium formate. So first part should be weak acid and second part should be its salt with the strong base. So this is known as the acidic solution, an acidic buffer. So what are the more examples of acidic buffer? So let's say we have a that benzoic acid, and here we have its salt COONA, or we have, like if we have acid like H2S. So in case of H2S, we have H2S plus NaHS, or we have HS minus plus S minus 2. So actually it is H2S plus NaHS, and it is NaHS plus Na2S. So it is acid and salt with strong base. Now it is also acid and it's salt with a strong base. When we have H3PO4, it has 3 acidic hydrogen. First is H3PO4, and if you remove or react with 1 mole of NaOH, it will form NaH2PO4. This is the buffer number 1. H2PO4 minus plus HPO4 minus 2. This is buffer number 2. HPO4 minus plus PO4 minus 3. This is buffer number 3. So these all are buffer. Means if I write the Na over here, the sodium, then also it is correct, and this is also it is correct. So in the question, so let's in order to form acidic buffer, we should have one acid and its salt with a strong base. So the following questions are given here. You have to predict which of the following is an acidic buffer. So first of all, we have to predict this is acetic acid NaOH. It will form CH3COONA plus H2O. So similarly, when 1:1 we have ratio given, so it will be and it will be this will the problem of salt hydrolysis. So it won't be a buffer solution. We have both. We should have both the salt and acidic part, the weak acidic part. So when we have it is CH3COONA plus H2O. Here it is 1:1 dash and 1 will form. So here we have acetic acid and sodium acetate. Here we have both the mixture. On the both the mixture, now we can call it as a buffer solution. So it is a buffer solution. H2S and NaOH in the ratio of 1:1, it will form NaHS plus H2O. It won't be a buffer solution because it is form 1 mole. We don't have any H2S on NaOH, so it won't be a buffer solution. H2S plus NaOH in the ratio 2:1. It will be forming. Will it be a buffer solution? Yes, it will be a buffer solution. It will form HS plus H2O. So it will be 1:2 dash and 1. So this both will be the buffer solution. Now we have H2S and NaOH. It will form Na2S plus H2O. First of all, it will form 1 mole of react with NaHS plus H2O. So it will and it will form 1 mole and it will be 2 mole. 2 mole of NaHS will react with NaOH. Now NaHS react with NaOH, it will form Na2S plus H2O. Now we have 2 moles of Na2S, 1 mole of NaOH. So it will form 1 mole and it will form 1 mole. Now we have salt, we have acid, which is a weak acid, and we have a salt. So finally in the solution we have, it can react with 1 mole of this, right? So finally we have Na2S and we have remaining of NaHS, which is weak acid. So it will be a buffer solution. Similarly, you can see the case of basic buffer. So what is the basic buffer? When you have a weak base and it's salt with a strong acid is called the basic buffer. So how basic buffer form, the process is the exactly same, but here you have to consider the weak base and it's react with a strong acid, where the strong acid is the limiting reagent, and in the final solution we have weak base and salt. So actually this was the introduction of base, the buffer. Now we're gonna study the separate what is the acidic buffer and what is the basic buffer over here, and we're gonna study also buffer action.